Hi folks, welcome to Lesson 6, Organic Chemistry with Priestland Science. We're going to use the same lesson format as per usual, so you can pause the video and collect your resources or rewind if you want to check something through. Let's start with your retrieval practice, so pause and retrieve. And here are the answers, so you can pause, check and revise. Slide 2, pause and retrieve. The answers, you can pause, check and revise. And slide 3, pause and retrieve. And the answers, you can pause, check and revise. And our final slide, pause and retrieve. And you can check the answers by pausing and revising. Today's lesson, we're going to look at the chemical test for alkenes, and we'll learn about alkenes in the process. You're going to need this document from Show My Homework, or you can pause the video and copy this down onto a piece of paper. Remember to leave a little bit of space to write down your answers. Okay, so we're looking at the chemical test for alkenes. Now, this brings us back to last lesson when we looked at cracking, and question number 1 is all about cracking. It says, what are the two products of cracking reactions? And in cracking reactions, we always make an alkane, which we've learned about in the past, and an alkene. Question number 2 says, what is an unsaturated hydrocarbon? 2 bullet points. That's essentially another name for an alkene. So unsaturated hydrocarbons are alkenes. And the unsaturation is about the bonds it contains. And alkenes are hydrocarbons with carbon-to-carbon double bonds. So with these carbon-to-carbon double bonds. Now we're going to have a look at the first 4 alkenes and name them and draw them. Now there is no methene. The first alkene is called ethene. And ethene, like ethane, has 2 carbons, but in between those 2 carbons, instead of a single bond, it's got a double bond. And now if we know that every carbon will make 4 bonds, well, this carbon has already used 2 of its bonds, so it can make 2 more bonds, 1, 2, to 2 hydrogens here, and the other carbon will do the same. So that's ethene, its chemical formula, C2H4, I think for obvious reasons. And then next in the series, after ethene, we use the same prefix. We have propene. So propene has 3 carbons, 1 double bond. I'm going to put it over here. Could put it over the other end, but it doesn't really matter. And then I've got a single bond here. Now I just have to remember that every carbon makes 4 bonds. So this carbon has made 1, so it can have another 3. Got to be careful in the middle here because this carbon has already made 3 bonds, 1, 2, 3. So it's going to have another hydrogen. It doesn't matter if I put it down the bottom or at the top. And then this carbon's made 2 bonds, so we can make another 2 bonds. So I'm going to put these over here. And then if I count the carbons, it's got 3 carbons. And if I've done it right, it's got 6 hydrogens. So ethene, propene. The next one, you won't be surprised, is butene. Butene has 4 carbons, 1 double bond. And then I'm going to put the hydrogens on. Just take care that every carbon is only got 4 bonds. And the fourth alkene is called pentene. Obviously, it has 5 carbons, 1 double bond, and then put the hydrogens on the outside. Now, you can probably see there is a pattern in the chemical formula here. We have, whatever the carbons are, we have twice the number of hydrogens. So the general formula for an alkene is CnH2n. Whatever number the carbons are, you've got twice the number of hydrogens. Now, what I want to do next is show you a little video about how we test to see if a chemical is an alkene.
Let's take a look at a test for unsaturation in hydrocarbon. On the left here in these two test tubes I have bromine water. You can see at low concentrations it appears more yellow than orange in colour, and at higher concentrations bromine water appears orange, as you see here. I'm going to use the darker solution so that it shows up better on camera. In these two test tubes I have liquid hydrocarbons. This is cyclohexene, which contains a carbon-carbon double bond in each molecule, and this is cyclohexane. It has no carbon-carbon double bonds. So let's take a look at the positive test first of all for the presence of a carbon-carbon double bond. What I'm going to do is going to take some of this bromine water. Bromine water is poisonous, so this experiment should be done in a fume cupboard. In a positive test for a carbon-carbon double bond, the colour of bromine will disappear. It will go from this orange or yellow colour to colourless, because the products formed in the reaction between bromine and the alkene are colourless. So I'll remove the bung here from the test tube containing the cyclohexene and add roughly the same volume of bromine water, and it goes. Put the stopper on here. Now at this stage, because the liquids are immiscible, the reaction would take some time, probably 30 minutes or more. But if I shake the two chemicals through one another, the reaction will occur very quickly. So at the moment we've got the bromine water on the bottom, that's an aqueous solution of bromine, and on the top we've got the cyclohexene. What I'm now going to do is shake the liquids through one another and watch what happens. And there you see the result. The bromine water has been decolorized. Let's try that now with the cyclohexane here on the right. So again, I'll add roughly the same volume of bromine water. We're expecting a negative result this time. We're expecting the colour of the bromine water to persist, to remain. Now there is another little bit of theory involved here. The bromine is currently dissolved in the lower layer, dissolved in the water, or aqueous layer. When I shake them, the colour of the bromine water will persist, or the colour of the bromine, I should say, will persist. But because bromine is more soluble in the non-polar solvent layer at the top, more soluble in the cyclohexane, it will swap solvents, and its colour will change a little bit, as you'll see. So let's shake them. And the colour, you can see, is persisting.
Okay, so that's the chemical test to distinguish between an alkane and alkene. We're going to write it down on our piece of paper here, just as a sequence of diagrams. So here I've got a test tube or a boiling tube, and in that boiling tube we have some bromine water. So I'm just going to label this as bromine water. And if you pay attention during the video, then you'll obviously know that bromine water is a kind of orange yellow color to begin with. So I'm going to write under here, orange. Now the next step is that we take our bromine water, which is still here, and we put in drops of the alkene. So this would be the alkene dropped in. And because it's an alkene, it causes the bromine water to lose its color. So we write underneath, bromine water decolorizes. Bromine water decolorizes. Now a note under there, note, alkanes will not decolorize bromine water. And therefore this chemical test is the way we distinguish whether a hydrocarbon would be an alkane or an alkene. Now, next step, I want you just to spend a little bit of time embedding that new knowledge. So a little bit of retrieval practice, self-test, peer test. So pause the video, just learn those basics we've been through in those 5 questions. Pause now. And here are your practice questions for today. You can print them from Show My Homework or do them straight from the screen. So pause here to do questions 1 to 6. Pause here for question 7. And here are the answers to questions 1 to 4, 5 and 6, and question 7. So that's it for today. Thank you for tuning in, and we'll see you for the next lesson.